Good. Hello, everyone. Welcome. Thank you for attending the presentation. For those who don't know me, I am the Big C chair for mainland Europe. This is a volunteer job. The people who pay my salary is the company Legrand. And my current responsibility is standards. So I sit in the standards committee helping other people to write it together. So of course, when I make a presentation, it's going to involve a lot of standards. So I hope I won't get too technical on you. So our cabling today is mainly designed for one type of application, which is IEEE Ethernet. That's the core. There are other ones, but that's the main one. IEEE ratifies Ethernet on cables. That's 802.3. But it's also ratifying wireless, 802.11, all the access points we buy at home. These are the guys who defined how they work. Today, we are going down, up to 40 and 100 gig on fiber, 25G and 40G on copper. There's a new one which goes up to 400G on fiber. And now we're also looking at PoE. PoE is also invented by the same guys because they decided that the access points right here would be able to deploy in a much faster method if you tell the customers they need only one cable and not two. Don't bring one power cable and one data cable, bring only a data cable with power inside. So that's a lot easier to sell access points, so this is why PoE was created by the same guys. The cabling, internationally, is defined by ISO. ISO has structured their documents into three main categories. The first one is on the performance and the design. So this is where you're going to find the classes. This is where you find the star topology, everything consultants or designers will use. Afterwards, there's the implementation, how to install it. And the first segment is the testing. Testing copper, testing fiber. What ISO does not have is the components. Components is actually for manufacturers. For a company to say my connector is compliant to category 6, it's not compliant to ISO. It would be compliant to IEC. So IEC defines the components, then ISO will say if you put those components together, you get a system compliant to ISO. Here, we are part of the ISO, generally, international. We're also part of CENELEC for Europe, which is very similar to ISO. On the other side of the Atlantic, there's TIA. TIA has the same structure: design, implementation, validation. But they have something else. They also have components. So in theory, the Cat6 connector in TIA could be different from the Cat6 connector in ISO. Of course, everybody talks together, and we try to do things intelligently so they are similar. But most products are not identical. So there are differences between TIA compliance and ISO compliance. The one thing that they do now is to use IEC, the same as for ISO, for the mechanical aspects. In the past, you could have had a connector compliant to ISO, which would not work with a plug compliant to TIA. That's stupid. So of course now they say, no, let's just use the IEC for the shape of the plug, durability, resistance, all of this, and then we can just have our separate performance. The copper categories. Now there's a long history from the first one, and the first copper category was not category 1. It was 3. So Cat3 had 10 meg, and here I've got already a fast forward, so I don't go through everything. 100 meg appeared on Cat5. And gigabit appeared originally for Cat5. But because gigabit required some other testing, PS Next, etc., noise between 4 pairs, not just between 2, it turned out that testing Cat5 was not sufficient. So they increased the testing and they said, you can test your current Cat5 and see if it works for gigabit, or you can install a new type of Cat5 which is already guaranteed gigabit. In the US, they call it Cat5 Enhanced. So it's basically a Cat5 which was slightly improved or just guaranteed compliant to gigabit. In ISO and Senelec, we have the same specifications as Cat5e, but we call it Cat5. So be careful on this. European Cat5 is the same as TIA Cat5e today. All the catalogs and brochures, everybody uses Cat5e because that's what people are used to seeing. But that's technically incorrect in Europe. Then Cat6 appeared. So Cat6 was in 2002. So remind me, Cat5 is compliant to gigabit. What does Cat6 offer? Still gigabit. Ah, so why do I need Cat6? Well, at that time, you didn't really need it. There was more marketing. So, what would come after gigabit? Well, 10 gigabit. Great. So we need a cabling system also for 10 gigabit. At the time, this is why Category 7 was created. Cat7 is a solution invented in 2002 to allow a future 10 gigabit. Now, at the time, we didn't know the frequency needed for 10G. So there was a decision made to say, let's go to 600 megahertz, that should be sufficient. Great, good choice. The technology to make cables at 600 megahertz did not exist unless it was fully shielded. UTP was not capable of reaching that frequency in 2002. And the other problem is that the connectors, those RJ45s, by the way, RJ45 is not a term. Who knows the real name? 8P, 8C. RJ45 doesn't exist. So that connector, the 8P, 8C, that we call RJ45, everybody said it's a telephone connector that will not go up to that frequency. It's not possible. So there was a choice made to invent 2 other connectors. You've seen those around probably. So Category 7 was created with only shielded cables with 2 connectors which are not the RJ45 in order to provide a solution for a future 10 gigabit. Let's move on now. And let's see, 10 gigabit appears in 2008, 6, and Category 6A appears in 2008. And the documents for 10 gigabit, actually it's Cat7A appears also that same year. The documents for 10 gigabit say that it will function on different types of cabling. And here we have to understand the market. You have a market at that time which still has a lot of Cat5e, quite a bit of Cat6, and then a little bit of Cat6a and a tiny piece of Cat7. Now, you're an active equipment manufacturer, and you want to sell a switch compliant to 10 gigabit. Do you want to tell your customer he has to throw away his old cabling and put new one inside? No, you want to tell him, keep the old cabling, it will probably work. So this is why there was a possible compatibility with Category 6. You had to retest it to 500 megahertz, retest Alien X, but it was possible. Then of course, it would be allowed on Cat6a, which is designed for 10 gig, and of course, 10 gig is also compliant on Category 7. One issue, when you create a whole system, you need the same category from one end to the other one. So a class EA, which is for made of Cat6a would have Cat6a components end-to-end. A class F would have Cat7 components end-to-end, including the patch cords on each side, and including the connectors of the patch cords. So now you look at the market, once again, and you ask the switch manufacturers if they want to make a switch which has connectors for this big piece of the market or other types of connectors for this tiny piece of the market. Geez, I wonder. So of course, they all made switches 10 gigabits with the RJ45 connector. So, which means that as soon as Cat6a was available on the market as a system, the Cat7 became more expensive for actually less guarantees on 10 gigabit. Cat7 offers other guarantees for other solutions. But for 10 gigabits, it's not the cheapest solution available. Cat6a was going to win. So, we needed another solution for the future. What was the future? 40 gigabit. 40 gigabit, we knew at the time was going to be around 2 gigahertz. It was already known. Products could not go up to that frequency. So Cat7a was created around 1 gigahertz, so defined to 1 gigahertz, with those similar type of connectors that we saw on Cat7 to offer the highest frequency available on the market. So customers could say, well, if I only want 10 gigabit, I'll stick to Cat6a. If I want 10 gigabit and I want also higher frequencies for the future, I can go for a Cat7a. 2016, 2.5 and 5G appears. Who knows what this is about? Now, Wi-Fi is improving. And we already have solutions since 2013 that can offer 6.75 gigabits per second total on the wireless side. So when you combine all the computers connected to one Wi-Fi access point, that's the total capacity. So if you have 6.75 on one side and a cable of only 1 gigabit on the other side, you've got a bottleneck. So you'd say to the customers, well, no, you want to cable it with category 6A. But again, you go into the argument of telling your customer, if you want to buy the latest access point, you have to change the cables. They don't want to do this. Customers want to say, no, I can just plug it in and keep the old cables, so it costs me less money. So 2.5 and 5 gigabits per second were created to allow people to install new access points on existing cabling. And it goes more on a best guess. So you say, if you have a Cat6 and it's short, probably it will accept 10 gigabits or 5 gigabits. If you have a Cat5e and it's long, it won't accept 5 gigabits, probably. But you never know. And then in between, it's just shades of gray. And if you want to be certain, you can test it. You can talk to the testing manufacturers out there. They'll tell you how to do it. So this allowed deployment on Wi-Fi on existing cable. The same year, Category 8 is ratified. And originally, it was only 40 gigabits per second. But actually, they added 25G. So we have 25G and 40G by IEEE on Category 8. But ISO decided to have two classes called Class 1 and Class 2. Wow. Are we getting mixed up now? Yes. So what's this about? Category 8 for 25 and 40G is designed for the data center, to cable between cabinets. It has a maximum distance of 30 meters. Do not install Cat 8 to 100 meters, there's no point. It's 30 meters. And On one side, we have the TIA Cat8, defined to 2 gigahertz, allowing 30 meters, and compliant to 25G and 40G. ISO class 1 has the same frequency, distance, and compliance. It has the same cables as the TIA Cat8, but they are called not 8, but 8.1. It has the same connectors also, and they are called 8.1 connectors in ISO, or IEC, I should say. Okay? So these two, Cat8 and Class 1, are identical. Then there is a Class 2, which has the same frequency, the same distance, the same applications, but it uses only fully shielded cable, the same as Cat7 and Cat7a, and only the same connectors. So the customer has a choice between the two systems. What comes after Cat8? Well, today, I can tell you that no one is working on a Category 9. I don't know if it will exist one day. I'm just saying that today, we don't care. It's not an objective. But there's a problem, is that 40 gig is 30 meters, and on the horizontal, we're limited to 10 gig. Why can't we find something else? Well, it turns out that because there's a 25G available, we know that it could work further than 30 meters. And you will see a 50-meter limit, probably, very likely, for Category 8. So 25G on Category 8 for 50 meters, and this will be to be used in office space for special requirements. Really, we don't need this for internet, huh? Okay, so that's the next step. Oops. Now I'll talk a bit about fiber systems. Fiber optic, just a reminder, the reason we use multi-mode is because of the price of the active equipment. Putting a network interface for multi-mode is always cheaper than single mode, but multi-mode cables are always more expensive. When we send a signal on fiber communication, we are working in a duplex method, where it's one send, one receive. So we always need 2 fiber connectors, and always a 2-core patch cord and a minimum 2-core cable.